then I would just like to welcome the speaker of today, which is Professor Tom van Woensel. Welcome, Tom. Tom is expert in operations and supply chain management, both here at Antwerp Management School, but also at the Eindhoven University of Technology. And on top of that, Tom is also director of the European Supply Chain Forum. So welcome, Tom, welcome everyone, and let's kick it off. Tom, the floor is yours.
So also from my side, I'm happy to give this webinar. And of course, I'm a bit biased because of experience of working with a lot of colleagues and companies. And as Eline already said, I'm mostly indebted to a few companies which are also in the European Supply Chain Forum. So if you're interested, I will give you a little bit of a few two slides or whatever on what that means and these kind of things. If you feel like you would like to reach out to me based on the webinar, or would like to get more information, or you do not agree, which I also hope, then just send a message or indeed give a shout out via the chat. And then I will try to answer any questions which you might have. And maybe it might be good that it could also be that I do not know the answer, but that's always interesting because then it's new research and it's new projects which could eventually come up with. So just a little bit about me. Eline already said so, but I'm actually I graduated in Antwerp. I did more or less everything at the University of Antwerp, and I'm having a double function, both at the management school, Antwerp Management School, where I'm the academic director of one of the full-time master programs in supply chain management, which is one of the largest programs for young professionals in the school. Then I'm also a full professor at the Eindhoven University of Technology with a chair on transportation, logistics, supply chain in general. And I'm also heading the Supply Chain Forum, European Supply Chain Forum over there. So in that sense, it is quite a long history that I at least I have been working in the field, and I'm of course doing that not alone, but at the University of Eindhoven, I'm working for 20 years. At the Antwerp Management School, I'm now there for more than 10 years, and most of the cases and most of the examples and related important, let's say, insights which we derived and tested are also coming out of this supply chain forum. And in this supply chain forum, we somehow try to connect talent, knowledge, and network together. And we do that by having a long-term relationship with companies. And that's important because in a supply chain setting or in operations setting, we do not have a laboratory where you can somehow play with and experiment, because our laboratory is actually up to a certain point, it is actually the companies. So we need to really work and reach out to companies and collaborate with companies. So some of the elements I will be discussing today are tested or developed jointly with a number of companies in this supply chain forum. So if you look at the number of the members we have, so you see that there are quite a lot of members in the forum, and each of these members have been participating in a number of the discussions and concepts I will be discussing today to have them fine-tuned, to have them better understanding, to somehow have a closer understanding about how these kind of things are going. So these are what we call full members. You see a quite broad variety of type of companies. These are what we call community members. Don't bother too much about the exact formulations, but you see that it is a nice mix of let's say more commodity providers into retailers, into ICT, into supply chain consultant type of functions, into even more pharma type of supply chains with buyer and so on. So it's a quite broad mix of different type of companies, which actually have been discussing with us a large number of these type of things, and which I want to share with you a little bit in this, of course, too short webinar. so that you also have a, let's say, just somehow disclosing a little bit about this kind of work we have been doing. And of course, just to make sure that all the information I will share in terms of the presentation, and also there is a white paper we will be sharing with you afterwards, so that you can also have a more in-depth reading if you are interested in reading more. Now, so just to give you a little bit of a background, or putting it a little bit into a broader perspective, is that there is, of course, and if I would ask the question basically to everybody, like, hey, what are important trends and future evolutions you see happening, then of course there will be a lot of people saying a lot of different things. But what you typically see is that there are many similarities among everything what is being said. And one element I usually make use of, or one report I usually make use of, is this logistics trend radar from DHL. And of course, it's maybe a little bit biased towards more service providing kind of companies. On the other hand, it is quite broad, and they update their trend radar regularly, meaning every 1 or 2 years they give an update about what they see is important, both from a technology perspective, which is the right hand side, then from a societal and business type of perspective, which is the left side. So you see that if you combine all these different type of elements, they end up with a trend radar, where you see elements saying this is relevant the coming 5 years, up to the coming 5 years, and this is relevant beyond the coming 5 years. And of course, you see a lot of different type of elements in there, which are all important in a broad supply chain type of setting. They are also not necessarily independent from each other. So it could be that, of course, technology is enabling, of course, certain things what you might see in society and or business. So there is not a complete independence from each other, but it is actually quite interesting to see where DHL thinks the supply chain and logistics world is heading to, or maybe more normative should be heading to. Could also be. Now, just to take a few elements out, because of course everything is interesting, but we can probably talk on each of these topics 1 or 2 hours more in detail, and that's not the idea of today, of course. You see that, of course, on the societal side, you see many of these kind of things coming in, like sustainable logistics, connecting it to even rethinking packaging, omni-channel logistics, the fresh supply chain, the silver economy. How do we actually get into the aging population? All very interesting kind of topics, where you see that also in science, but also in practice, a lot of people are discussing and moving into these type of directions. On the other side, you'll see a quite interesting line of thinking, which is mostly related to the use of new technology, up to extremely far away kind of things, like maybe drones flying around. The unmanned aerial vehicles is just a nice name for a drone. 3D printing, all these kind of things seem to be quite far away. On the other hand, there are a few elements in there where you see that many of us are actually working on and moving into. Just see big data analytics, the Internet of Things, robotics and automation, artificial intelligence, up to self-driving vehicles. That's something. Yesterday I had a chat with somebody in the Netherlands, a company who was making this kind of automated vehicles for in a logistics setting for ports and production to warehousing kind of thing. So they actually are working on that, but it needs a lot of intelligence to do that. And that's where you see this line from the red dot going up, from big data to Internet of Things, automation, AI, whatever that means, and so on and so on. And of course, you also see a bit more on the right side, something related to that, digital twins. Digital twins are, of course, very important, advanced simulations, if you want. So all these kind of things are somehow connecting to the role of new digital information, the new digital technology, the advanced technology related to data, to potentially moving into AI. That's basically an important line of thinking in this trend radar. Now, if you also connect that to talking to companies, talking to all these companies I just showed you in my list, we also do some of these kind of executive tables and these kind of things. And then you see that there seems to be a lot of boardroom discussions about what can we do with AI? What can we do with artificial intelligence? How do we need to move into artificial intelligence? And maybe the sort of zero order kind of question was also, what actually means AI? What does it mean? What is it? What is it not? And sometimes I even get questions like, Tom, we need AI because we want to get rid of planners. We want to get rid of people and we are going to use AI. Of course, I'm not sure whether that is the right question, but at least it shows a bit that that supply chain managers, people, operations people, companies are also more and more thinking about how can we do this digital transformation and make use of this digital transformation into a certain way. I'm not going to talk about everything here because this is a fantastic area where we can already do a complete masterclass for 4 or 5 days on. But I think the point is that it is an interesting domain, and it is actually a new domain which is moving forward, and that where we need to have a proper understanding about what does it mean, what does it not mean. Like, remember the question from my colleague company saying, yeah, what does it actually do? Where do we need to go to, and so on. So what the remaining part of this session, I would like to spend a little bit of time on the words which are being used quite a lot. I want to outline a tool which we developed, which is this data ambition matrix, is saying somehow trying to identify as a company on the analytics data level, on the intelligence level, into trying to get into this maybe more autonomous type of settings and so on and so on. Where are we as a company? Where do we want to be? And what do I need to do to go from the place where I'm now to go to my target, whatever that might be. So this is a tool which we developed in the supply chain forum in collaboration with Antwerp and Eindhoven. And I will give you a bit more information on that. And then I will give you an example about how we did one of these kind of more, of course, very, very specific example in how we worked into adding more intelligence into an inventory management type of setting, which is, of course, one setting. I could also have chosen transportation or network design type of settings where we also have been doing quite a lot of research in. But given time, I only will give you the inventory example for today. So this is the agenda for today. If there are any questions, like Elin said, just put them into the chat. If you would like me to clarify certain things, also put that into the chat. And I also keep half an eye on the chat. And if it is really important, Elin will also shout out to me. So don't be shy. That's the idea. Okay, so let's go into data science words, or data words, or analytics words, or whatever you want to call it. And I think it's quite important to somehow agree upon these kind of things, because I also see that a lot of people are using these words, but not necessarily completely understanding what they mean, or they think it is something fantastically new, or it's actually sometimes, to put it a bit unpolitely, maybe old wine in new baskets kind of ideas. And that might be because I'm doing these kind of things for 25 years already, that I might think, yeah, this is similar. On the other hand, there are, of course, important new factors to be discounted into the picture. So it might be that I'm making it a bit black and white in this talk, but this is just mostly to make the point very clearly. So data science words. So if I look at this digital transformation type of processes, or if you look at how we manage these kind of processes into a supply chain, or we try to manage these kind of things, is of course the standard story, if you want, where we somehow try to get this data, this messy data. We are going to make use of this messy data by somehow making use of what they call analytics. I will say you something more in a second about that, so that we can make better decisions. Now, of course, in this setting, it sounds like it is a sort of a quite stationary type of thingy, or quite one-off type of process. But this left-hand picture, which is from an OECD report on the use of data and the use of digitalization into the supply chain and whatever, you see that it is actually an ongoing process which needs to be active all the time. Right? We make decisions. These decisions, of course, are there to somehow create value, whatever that value means. It could be profit for a company, it could be well-being in a societal type of context, whatever. You make decisions, but the output of these decisions, and you observe, of course, again, output and results and new demand and whatever have you. That's what is called this datafication and data collection, ending up in this big data part, where we end up with, of course, big data in itself, that people tend to say this is the new gold, or this is the gold, whatever. It's of course a bit nonsense, because it has no value until you basically extract information out of your data. And that's where we use this analytics discussion. This is the next from big data. You use analytics to actually go back into your knowledge base, and the knowledge base is being used to make decisions. Now, just to give you a short example about how this could work, if you have data on sales, and of course sales is not demand, but you somehow try to make use of your sales data to somehow get a good understanding of what is my demand distribution, or my demand process, or the underlying process leading to the sales things. So you would observe datafication and collection. You would take sales, all the sales data ends up into big data. We are going to make use of some statistics type of techniques to actually derive a good distribution, statistical distribution for demand, which we put into the knowledge base. And we are actually using, up to a certain point, information out of that distribution into the decision making, in terms of how much inventory do I need to put there, how much transportation do I need to line up, and so on, so on. And of course, you need to somehow do this mechanism all the time to make sure that your underlying demand process is not changing, because and if it is changing, that you would like to pick it up relatively fast. So it does not, that the value of sales from 10 years ago has very little value maybe to the sales of today. And so there is a difference there in terms of what you can make use of it. So it's basically doing that all the time and collecting this important information, because we do these kind of things, digitalization, digital transformation, at the end of the ride, to make decisions, to make good decisions, or to make better decisions, or to make profitable decisions. So depending on what your KPI will be. And of course, there is a lot of tacit knowledge of people, that the people are doing quite a lot of things, of course, based on their experience. You would also potentially take that into account as well. But that's something I will tell in a few minutes a bit more about how to potentially you could do that. But of course, this tacit knowledge is also somewhere buried into this data. Right? It's somewhere there, because decisions are made by people in many cases, and in this case, there is also knowledge from people into the outcome of these decisions as well. So now analytics, I already mentioned this a few times. You see that this is the Gartner type of storyline, and you will find, if you look online, many of these kind of things, and they all say it's all analytics. Yeah, I can imagine about something like that you want to call it analytics. That's fine. And they typically talk about descriptive to diagnostic to predictive into prescriptive type of analytics. And you see that they move into from information to optimization. Now, just to give you a little bit of an idea, if you look at the descriptive analytics, what happened, that's of course looking back, hindsight. It tries to understand what happened. One way of doing that is calculating means, is calculating standard deviation, is calculating other type of information. So this means that there is some statistics, if you want, descriptive statistics, you might want to call it in the old days, to somehow identify what happened. And then you do diagnostic analytics, where you try to understand why this happened. Again, this is why did it happen? I guess some of you in the past or still are studying, there is something which is called regression analysis, and everything related to that. There you will see that you try to somehow understand what you saw, what you observed, the what happened, and you try to connect this to a large number of drivers to identify why did this happen. And then regression analysis is, for example, one of these techniques which is being used, which you could use to actually identify that. So that's what they call now more diagnostic type of analytics. And then, of course, predictive analytics is more and more explaining into the future, what do you think will happen? Now, there is one thing which is more or less as old as it can be. It's the prediction of the future. And so in that sense, if we do forecasting, if we use these kind of models for maybe advanced models from regression or other type of models which we have in the forecasting literature, we can of course make them richer because of the magnitude of data we have available. But this is a sense of sort of a forecasting mechanism. And of course, if you push it a bit further, then you end up in these prescriptives. How can I make it happen? And that's what they done in this Gartner type of cycle, more and more talk about optimization, where you typically see quite a lot of these more OR, operations research type of techniques, mathematical optimization type of models, where you do maybe linear programming or integer programming type of techniques, where you somehow try to make the right decisions. And of course, taking into account this maybe richer set of data and information you have available through this cycle I talked about, how can I actually make use of these more larger data sets, larger information sources into the decision making? And that's where you somehow do prescriptive analytics. So up to a certain point, I think if you look at this continuum, there are of course many elements in there which are similar to what people already are doing. They just call it now analytics a little bit. So for me, this is, I think, relevant in the sense that there is much more data available. The challenge is also on the data. How do I make use of this data? There is, of course, a lot of technology that can actually mine data in a much better way. But the basics type of things are still related to statistics, advanced statistics, into multivariate data analysis, into factor analysis, regression analysis, into optimization type of models, which we have been studying more or less the last 50 years in an OR type of context. So to what extent is it very different? I'm not extremely certain about that, but it actually is good to be aware of the concepts. Just a small side note, I'm also part of the Institute for Operations Research and Management Science, which is a US-based institute. And I think at a certain point, we all were moving into using they were labeling us more as analytics type of people rather than as OR and management science people, although we were not doing very different stuff. So that's quite of a funny kind of observation to see that all of a sudden my field changed names almost, which was not very clear to me. Now, another one in there is, of course, the making use of advanced machinery, which is then typically you end up with machine learning type of concepts. And machine learning is, of course, a little bit differently, is that compared to traditional programming, you basically try to program and you connect data to that and you're looking into the output. Machine learning really tries to have the computer learn what is the policy in between, what is the rule to go from data to the output, which you give both as input, so that you can understand what is the policy, the program to go in between. So you're not learning, or you're not working generating output based on a logic you basically put in yourself, but you're trying to learn based on the combination of input and output, what is the policy, what is the rule to go from this input to the output. And that's actually quite interesting, because if you remember that I said that the role of a planner is important, the role of people is important, you can actually make use of this input-output kind of combination and try to understand the logic that a planner is being using. And this might not be necessarily the same logic as what you actually would have done in a traditional type of programming setting. So this is the main idea of doing machine learning. And of course, here again, there is a variety of learning mechanisms available where we somehow try to make use of training the world into a good way. So you see that there are, of course, things like supervised and unsupervised learning. These are mechanisms where we combine supervised learning. We give the supervisor, or we give the output immediately to the learning mechanism. For example, the many examples are also in image recognition. So you would mean that you give a lot of input images of dogs, and you say this is a dog, and you want to make sure that the learning mechanism understands the logic of getting to understand that if he sees an image that this is a dog, that you can start learning that on with the lots of pictures of dogs, and then the policy should be able to understand if you give him a picture of a dog, this is a dog, yes or no. And of course, that's already quite difficult. And if you do unsupervised learning, you basically give a lot of information to the learning mechanism, and you let it learn itself that this is a dog and this is a cat and this is something else. So this is of course a little bit trickier, and you see that most of these image recognition or image search things or trying to identify people in pictures, this is all based on this type of technology in supervised and unsupervised learning. And of course, it is a bit like it is based on, again, quite known statistics like cluster analysis, factor analysis. So quite a lot of these this kind of data analysis type of techniques, multivariate data analysis type of techniques are the core in these kind of settings. Interestingly, what is easy for humans is usually difficult for a computer. So recognizing a dog is very easy for a human, but if you give a picture of a dog to a computer, it just sees pixels and zeros and ones, and then somehow understanding that this is a dog, that is actually very difficult for the machine. And the other way around is also sometimes the case, because if you see what is difficult for people playing chess or playing some other type of games, this is relatively easy with these new techniques for a computer. So reinforcement learning, I'm skipping the semi-supervised, not so dramatically important. Reinforcement learning is really about reinforcing good decisions and penalizing bad decisions from a sequence of actions. So the example, of course, you have is there is a robot in the room. He needs to go from one direction to the other direction, and he sometimes hits the wall, and then he needs to go back to the starting point. If you repeat this exercise a number of iterations, he will find out what the good policy would be to move from one side of the room to the other side of the room. There are very similar type of discussions about how can I learn an adequate policy for inventory? How can I learn an adequate policy for dispatching drivers and these kind of things? Now, and then usually in the same line of reasoning, in the same line of discussion, you see that people then start talking about, hey, this becomes AI. Because if I have an intelligent system that can learn, that actually is able to combine all these different elements, that we actually can do that in an autonomous way. And then we end up into a sort of an AI type of definition. And that is somehow autonomous thinking and doing that completely independently of people and planners and whatever have you. Now, of course, you see already that there is a line in there, that there are different type of mechanisms in learning, what you need to get into being able to do this more or less autonomous type of decision making and these autonomous learning kind of mechanisms into what might be a definition of artificial intelligence. Now, in a sense, if you take that part, then you see that in many discussions I had, is that this autonomy seems to be a holy grail for a number of companies, and they want to have more or less autonomy, and they want to have somehow autonomous decision making. Everything needs to be done almost independently of people, and human error should be taken out, and whatever type of buzzwords are basically passing by at that moment in time. Now, what I then observe is that quite a lot of companies are actually not having their basics right, meaning they are not necessarily collecting the data yet, so they're not necessarily doing this cycle already in a good way. And in order to be able to get into more autonomous and this advanced type of decision-making type of things like supervised or reinforcement learning type of mechanisms, whatever have you, yeah, then you need to have, of course, collect data. So you need to be able to monitor. You need to be able to control what you see. You need some optimization type of techniques before you really can go into autonomy. So if you see that, if you say the AI, artificial intelligence, becomes something like we want to have autonomous decision making, completely humanless, and there needs to be some learning mechanisms in there, that is fine. Then you basically need all these different elements in order to be there. So you cannot run before you start crawling and walking. So the question becomes a bit, as a company in this transformation process from monitoring to autonomy, yeah, where are we, and are we doing already everything in the right way? And monitoring might be, of course, you could also say this as we collect data. That is fine, but I also observe that there is a lot of data collected in different silos, not necessarily talking to each other. A lot of data is collected into the heads of people. So again, this tacit knowledge, and how do you make that explicitly so that you can actually improve upon your decisions and you can control for things that are going wrong up to optimization. So if you cannot monitor, you cannot observe the state of the system, then it means that we cannot even talk about improving certain things in terms of control and optimization, let alone talking about autonomy. So this kind of trajectory, if you want, or maybe if you want to say it a bit more into the title of today, this digital transformation type of process is, of course, putting all these different elements together, from the data science part, the learning part, into what are we doing and how are we doing that into a proper way. So it's quite a challenging discussion, and I'm aware of that. And I also we send out every year 50, 60 of our students, of our talent, in Eindhoven, and every year 40 of our students in Antwerp. We send them to companies to work with companies on company-based projects. And then where you see that it usually goes wrong is to the moment the students ask more data, more good data, and complete data. And because all the companies, they always want to improve upon something, optimize on something. But in order to do that, we need good data, or we need to have at least an understanding of the current processes, which is usually supported by data. And that it's a funny, let's say, discussion students have to come to the conclusion that apparently not everything is collected into the right way, and so on and so on. So, okay, I don't want to make it the data type of talk, but still it is, of course, for me, an important building block into this digital transformation towards autonomy. Now, having all these observations, like, yeah, companies seem to be at different type of levels into the data use, the data availability, into also different type of levels into what they can do with the data, how they can learn from the data, what is the knowledge base they have themselves into the HR side, who is able to understand this kind of concepts. This led us to develop with these companies the data ambition matrix. In a sense, you could also say this is sort of in your digital transformation process, it helps you to somehow support where do you want to be, where do you want to go, and what do you need for doing so. So I just want to take 1 second to be silent to see whether there are any questions so far. If there are any questions, just put them into the chat.
No questions so far.
Good. Then the ambition matrix, it starts from the the Porter value chain model, which is a quite standard type of setting into a supply chain type of setting. It's of course a very high level description of your value chain or your supply chain, but it somehow really aggregates a company into this block where we have the primary activities on the bottom line, and we have support staff functions to actually support these kind of primary activities. And if everything goes right, there is a margin, which is of course adding to the company's kind of value at the end of the ride. So what you see is these are typically not always the case, but you see these are very high level, a number of functions you could identify into a company which are there, which are all working, hopefully jointly, merrily together. Now, what you see is that that in many cases we have data in functional silos, what we call. So it seems that each of these functional silos has a own database. And database probably sounds a bit optimistic in some cases, because you can also see sometimes these are Excel sheets. These are printed thingies. These are whatever type of variations and not necessarily aligned with each other. So you see that there are these kind of silos, and there are this kind of own type of home-brewn kind of data sources which are not necessarily connected to each other. If you move that one further, you see that there are quite a lot of companies actually acting around these kind of ideas. Now, there are sometimes companies who are a bit further away or further ahead already, and they are moving to what we call partial within firm data integration. So they're connecting already into the company a number of important, let's say, activities into a single database, and somehow making use of the joint database setting, so that at least there is a more common kind of truth. They are looking into similar kind of things, and that they align already a little bit more. And of course, if you take this to the next level, then you end up with this kind of enterprise data storage type of things, which are of course more the full within firm data integration. So you really are connecting everything to each other. Then you might think about, even maybe not a very good example, but these kind of SAP systems or these other ERP systems, which have the potential to somehow be able to access data everywhere and to potentially do something with that. Although, of course, many of these kind of things are very transactional based, which is maybe also not preferred in certain cases. But you see that we go from silos to a partially integration to, in the firm, in the company, a full integration of all these kind of elements which are happening. I think I also know that there are a number of companies who claim they have this, until you start asking a bit more, and then you see that they are sometimes more into this partial integration, and so on, so on. And of course, this means, this kind of full integration means that there is nothing else anymore left in other Excel sheets and whatever have you, or other kind of home-brewn kind of things by colleagues who like programming and do a lot of these kind of things. Now, so it is both real time and or it can be both real time, but it could also be just a sort of a data warehouse considering your past information. I will get back to that in a second, Dominique, because that's another dimension into the matrix, into what direction you want to move with your data. If you want to have it real time, this has different requirements than if it's more sort of a collection of information from the past, which you put into a data warehouse somehow or a data lake and do something with that potentially in real time. So I will get back to that in a second, so bear with me for 1 or 2 slides. Then if you put, of course, the company in a supply chain, then it is clear that supply chains are, of course, talking to each other, or should be talking to each other, and that the outbound of the one is the inbound of the other one. So if you can somehow integrate these kind of, let's say, integrate on a data level, exchange these kind of things on over the supply chain, then of course you get into a larger type of pictures where you somehow try to connect dots to each other, and you try to exchange data with each other via EDI and whatever other type of things, so that you can get into a more supply chain type of integration with your first tier suppliers, second tier suppliers, maybe even further deeper into the upstream, up to downstream. How do you connect all these kind of dots to each other? Do you want to do that? Of course, there is a lot of value in terms of knowing what happens downstream, because you can organize yourselves upstream into a good way. And all these kind of facets are, of course, facilitating data exchange, but it also means that the maturity of your suppliers needs to be of a certain level, and the maturity of your customers also needs to be at a certain level in this digital transformation process. So you probably need to move forward more or less together in order to be able to achieve these kind of things. So this is supply chain type of integration. Of course, this gets more and more complicated because we have the market, of course, in there as well. There's not one supplier, not one customer. There are many, many more. And of course, there is a lot of extra interactions because we also have competitors. And these competitors you might also want to exchange information into your, into this type of, maybe on similar type of functions. So in this case, we call this a full market data integration, where you somehow try to connect everything together and somehow connect to everybody into the supply chain, including your competitors or colleagues, whatever you want to call it, and making sure that you have all this data available and to work around that. And if you work around these kind of steps, then we see that you move from a sort of a very siloed approach to a more or less almost completely integrated type of approach, where you somehow connect to everybody and in the market, and of course the whole continuum in between. This becomes sort of where is my cursor? Here it is. Then we get into the matrix, what we develop, and then this is what we call this data ambition matrix. We have a 4x4. It's a bit more advanced than a business school matrix, which is usually 2x2. So we moved into a 4x4, where you see that the columns are this data in functional silos, where you have how do you go from silos to integration to more data integration, market data integration within the firm integration. And then the other level is a bit where I think Dominique was also referring to, is that what do you want to do with this integration, with this data? How far do you want to go with that? And what do you have available in the company? Where are you in the company in terms of your people, the HR component? Do we have the right talent in the company to actually make use of this kind of, let's say, more advanced type of information which you could generate by integrating more and more? So you see that we start from no knowledge available, the lowest row, to maybe we want more in-house knowledge available. We are using the data more in an historic type of perspective. So more like, I have this nice data warehouse and I take some information out of that and I do something like maybe every day or every week, I use something with it, I don't know, up to in a real-time setting that you almost immediately sense what is happening and you respond in Philip's language, sense and respond type of things, that you immediately try to actively work around the data, making use of the data, and immediately repositioning resources, reorganizing production, whatever you want to do with that. And then these are the 4 levels going up into the matrix, and then you see that this gets 16 cells, and then it is quite interesting, and that's usually the exercise we do with companies. And I will give you the white paper in the emails afterwards, where you of course can do the exercise with a number of companies to identify where are you now. Are you more in B1 or A2? Are you more in C1, C2? Where do you want to go to? Maybe do you want to be in D4? Do you want to be in C4? Do you want to be maybe just B2? That's already good enough. And then the question becomes, hey, if I want to increase in the knowledge levels, then you need to probably reach out to management schools, to business schools, to engineering schools. You need people to be able to do that. You need other training. You need to work together with on master thesis type of project to basically build up this expertise into the company. And of course, maybe some technology is needed, and especially also on going into the columns from left to right, from data functional silos to another side. You will also probably need some more information to do that in a proper way, and more technology to do that in a proper way. Now, just to give you a little bit of a wrap up on this one, I did this a few times with companies, this set of companies from the beginning. And interestingly, many of these companies were positioning themselves around the lower left corner, A1, A2, B1, B2, they were somewhere over there. And they wanted to be somewhere into the direction of D3, C3. Some of them might be wanting to go even into a market data integration, especially the ones which are much more integrated type of companies. They wanted to also have much more, especially first years up to maybe second tier suppliers and customers. They wanted to somehow have this more integration part. But many of them were actually saying that they were not there yet, and that they needed to do a lot of other stuff, of course, as well. Another one, which I also did once, which was also a funny one, I did this once with 20 people, 20, let's say, middle management to senior management people from the same company. And then you would expect that they would all say the same, we are all in B1. But finally, also there, you saw that even in the same company, they were positioning themselves everywhere. And there was a huge discussion about where they are and where they should be there and why they are not there. So it also raises the awareness into the company about, yeah, what do we want? Where are we? And even in the same company, it's not necessarily the same. So if you talk about digital transformation, yeah, this might be a process you might be looking into. It, of course, it's a very high level description based on this Porter's value chain, but it helps to somehow structure your thoughts and to see where you need to go to. I will give you the white paper, so if you want to read more, go ahead. If you want to discuss more, I will be extremely happy to further discuss this more in detail where it is where you would like to hear more. So one thing in this process is that I would like to give you a short example. So I would like to spend a little bit of my last 10 minutes to discuss how did we actually make use of some of these elements to get into using data to improve decision making. And it is, of course, partially because we were, if you look into this data ambition matrix, we were working together with the retailer, and we were basically building ourselves a data warehouse, if you want, which was combining the individual silos from sales, from inventory, from the planograms into a store, and these kind of things. We tried to combine them into a coherent decision-making tool, and we tried to learn from that, like, can we actually improve upon the decision-making into putting inventory into the shelves, which is a very straightforward process, but it's a quite rich and interesting process. It also goes a bit into the same direction from we are monitoring, we are taking data, we are learning from this data, that we try to basically improve upon decision making. And of course, there is a little bit of autonomy in there, but there is not much important autonomy in there as well. So let's move forward. So we are this one I wanted to show. They're in a retail setting, and this is also one of the companies in the supply chain forum we did this work with. It is, of course, everybody knows the retail setting, supermarket setting, is that there is, of course, shelves. We need to fill up the shelves. There are checkout counters. There is people walking into the store. It's a quite complicated type of environment from a sales perspective, but also in an inventory control mechanism and filling up shelves. There is people working in the shelves, in the store, filling up these shelves. There is a workforce which needs to be available. We typically have a sort of a pattern of sales, which is more, let's say, we sell more usually towards the end of the week. In the beginning of the week, we do not sell too much. All these kind of things are there. And this is all controlled via, in this case, what we call an automated store ordering mechanism. An automated store ordering mechanism is an inventory control rule, which is somehow behaving like, at the end of the day, we collect the point of sales data. we process the point of sales data into the inventory records. And if my inventory falls below a certain target, I order. If not, I do not order. So it's a very standard type of reorder type of policy they were using. Of course, we have some case pack discussions in there, because if you order something, you get them immediately into a case pack of 12, 15, whatever, and so on. So if you take these kind of things into account, this is a quite, let's say, rich type of environment where you where there are quite funny kind of things happening. So we collected data, and I need a bit of time to explain this graph. We collected the data, so we asked all the data in terms of sales. What did you order? We did a simulation. If you want, in the modern words, we made our digital twin, if you want, which is mimicking their world into a very good way. And we were comparing then basically what we saw versus what the simulation digital twin said it should be. And this graph basically shows you for body lotion, a medium moving type of product, that you see that the ASO, the automated store ordering system, let's say this is our digital twin, which we generated ourselves, is ordering quite close to the sales pattern, which is the blue bars. So you see the blue bars, and the sales, the ordering of ASO, the system orders are very close to this sales pattern. That's because we are in a minimizing of inventory type of policy, and we are putting inventory right at the right moment just before. And if the lead time is 1, then you see that is very close to each other. Lead time and review period is very close to 1, so then you'll get into a pattern like this. Now, the data itself, which we collected about what actually happened, was actually showing something very differently. So you see that the actual orders were all moved into the, let's say, first days of the week, while in the end of the week, the store managers did not order anything anymore for this specific type of product. So they moved from the end of the week to the beginning of the week, their orders. And they made use of that into, shifting orders, advancing orders from end of the week to the beginning of the week. So this was quite an interesting observation. And again, this is an observation and nothing more than that. And of course, this is one item. And we also try to identify why is this happening. But first, we also try to identify, is this something generically happening? And we then looked at more or less something like 7,000 or 8,000 stock keeping units, so 7,000, 8,000 SKUs, which we used. And we looked at what is the range of a variation between the lowest and the highest. If I somehow use this, if I calculate these daily shares over a full year. And then interestingly, you see that the range of variation of sales is 16%. The system, the digital twin, was imposing a range of 24 versus min versus max, but actual orders were 13%. So what does this mean? In a sense, the store managers were actually going to be managing that process into the inventory process into a more stabilized pattern, because the store manager did not only care about the inventory, but he also cared about workload balancing into the store. So in our discussions with the store managers, we identified that apparently the store manager had a much richer type of policy program, if you want, in mind to make these decisions rather than only the very narrow inventory policy. Because he took into account the fact that the case pack size might be larger, some of the shelves were smaller or larger, the people in the store were not always busy in the beginning of the week, but they were very busy at the end of the week. So he knew a number of products, he characterized a number of products for which he knew he could advance their orders to the beginning of the week so that they actually had a more balanced type of workload profile. Now this gets interesting. This is very interesting because then if you know the knowledge, the tacit knowledge of this manager, and if you can somehow identify this knowledge, so we go from descriptive analytics to almost prescriptive analytics, if you want. If you can somehow grasp that behavior and we can put that back into the decision support, you'll potentially get better decision support. Of course, it means that there is some, we need to do some value check and whether there is really, that is not something stupid what is happening, but all these kind of things were double checked here as well. So there was really value creation by the store manager. So, and if you take that perspective into account, then we said, what can we do now? We observe that, and let's make use of this information to improve decision making. Now, this is, everybody thinks, hey, this is fantastic, this is new, but there is already one of the early papers by Bowman in 1963. He did this already into a production type of setting. He looked at what happens in a production type of setting, what are people doing. I'm translating that into management coefficients, and I'm putting these management coefficients back into my decision support system, and it improved. So this is already very old type of kind of work. And we use that work into this order advancement idea. We developed an order advancement index, which we use to somehow move into making use of that information into my decision making, into an inventory control rule. For the sake of time, I will not bother you with how we did all these kind of things, but how we actually processed all these kind of things. The main thing is you need to know is that we took the logic, we identified a good model, a descriptive model and a prescriptive model for that logic, and we put that back into, we upgraded the policy in our digital twin, and then we run the world again for the same year of data, and then we saw what happened if we used that improved policy. And then you end up with these kind of different lines, and I will take one example out. You will see that if I take S5, so store 5, which is the circles, you see that if I would not interfere with the system, that is the standard system, without interfering as a store manager, but also just taking the output of the system, I would have this workload imbalance of 35%, which is this upper corner, 35% over there. Then if you see S5, the separate dot, that is what the store manager was doing. So you see that he goes from 35 to something like 20% in terms of workload. So he was already improving that. If we make use of our system, if we make use of the improved decision-making system, you follow the line, the connected line down, you see that around this 1.2, this is a sort of sensitivity, we could reach somewhere a workload imbalance of something like 5 to 10%. So by adding intelligence to the system of the store manager into the system, we actually were able to further improve the system. And that is, of course, a very generic effect what you see, because a store manager is human decision making, and a human is not always consistent in his decisions, and he's not always making the same decisions, and he's not always making. Store managers sometimes were on vacation, then somebody else was taking the decision. So that's why we cannot fully get the full benefits out of that. So you see that this, of course, has the potential towards getting rid of the planner, getting rid of the human decision maker by somehow making use of the information, the data in the system, and understanding that and improving upon the decision making. Maybe this is digital transformation. Maybe this might be artificial intelligence, all these kind of things into that direction. I'm not sure, but at least these are interesting kind of concepts and reasons which might be extremely interesting to look into. Why the coming 5 to 10 years, there is a lot of challenges coming ahead. And again, these are really interesting kind of phenomena which might lead to, what is called digital transformation in supply chain management then. So to wrap up, I hope I gave you a good overview of my view, our view on how you manage this kind of transformation type of processes from more or less making use of this digital transformation. It is mostly focused on the use of data, AI, and these kind of things. There is, of course, a lot of technology enabling these kind of things, and we did not talk about that, but think about blockchain and all these other kind of things which potentially could enable to do that, but that's a very different type of story. But once you have this technology and you have the data, then of course you need to have your processes right to actually make full use of these kind of benefits which I have been talking about in this inventory type of example. Just to shortcut, the example with the retailer is of course not done. We did it in our digital twin, but we did not. The retailer did not transform its processes because of that, because this was extremely difficult to connect planogram databases to inventory record accuracy to point of sales, all these kind of things. Integrating that was at that time a bit too far away to actually move into to put that into a working kind of setting. Having said that, I thank you for your attention, and I'm extremely happy to take any questions if there are any questions.
Yes, Tom, thank you so much for your presentation and for the webinar. And indeed, we have some questions, of which some you have already answered whilst you were giving your presentation, such as the question from Dominique on the Porter model. I don't know if you want to add anything to that on top, Tom?
Not necessarily. I think I answered that up to a certain point. But if it's not clear, of course, I can answer more. But I think it's clear that it can be used in both dynamic, real time, up to almost a sort of a in hindsight type of setting. That's all possible, of course. So.
Yeah. Well, Dominique, if you want Tom to dive a bit deeper into that, or you have a follow-up question, feel free to drop it in the chat now. Then there was a question, Tom, as well from Philippe Dujardin, but I don't know if you answered this one or not. It was a brief one about whether is procurement a support activity. I would rather call it a primary activity. What are your thoughts?
I did not answer that one, but let's say that you can use the Porter model in a variety of type of activities, and where it is, I think there is a lot of literature on let's say Porter plus type of models, and I might agree with you even on that one, but let's say that's a very different discussion. So, but it's one framework which we just used, and which is a quite common one. But of course, again, every framework has advantages and disadvantages and shortcomings, and this might be one of them, depending on how you look at it.
Okay, thank you. There is also, well, not sure if it's a question from Siegfried about Gaia X. It's not really a question. Maybe it rings a bell for you, Tom. So maybe Siegfried, if you want us to go deeper into that, feel free to add some more information on what you would like to know about Gaia X. But then we have a question from Ivy. And Ivy is wondering if we can use artificial intelligence in dentistry. So, yeah.
Interesting.
An interesting one. I'm intrigued.
I have to give this one some thought. That is not my natural sector to talk about. So in that sense, maybe in terms of better intelligence about the patient's customers and how to do something with that in terms of having a better way of putting them into the right moment at the right moment in time to come back. But this is something I have no idea. Maybe also AI in terms of how some dents are organized, or tooth are organized, better said. I have no idea. So it's
I briefly Googled it myself because I was intrigued, and there is actually quite a lot moving in the artificial intelligence in dentistry. But as you say, Tom, it's not your area of expertise. So maybe we can move to a different question then from Ali Reza. So nowadays, thanks to technology, data integration and data operation play important roles, especially in the case of supply chain and logistics. But what technologies, both software, hardware, are commonly used in digital transformation and data-related operations?
Yeah, so there are a number of course, you see all these, and probably more people are more knowledgeable on that, but you see, of course, that moving from 4G to 5G, that actually gives you the promise of having more data available at that moment in time, at any moment in time, readily, fast, and these kind of things. all the systems where you see that SAP is also moving more and more into the cloud, which is of course more software type of systems where you could somehow integrate everything. There are also, if you look at these industry reports, there are, I think at this moment in time, hundreds, if not thousands of startup companies around data, collecting data, somehow doing with something like data, which is then resulting in this BI tool type of thing, business intelligence type of thing. So there is a lot of these kind of companies who are there. I'm not sure. It's quite interesting. They get a lot of money. Venture capitalists put a lot of money in them. But what you sometimes see is that they, I'm not a big fan of many of these companies because they generate, how should I say, they generate a hammer, but they are not necessarily, they are looking for nails to use their hammer with. And then you end up with something like developing a fantastic product, but not knowing what is the domain usage you need it for. But there is a lot of kind of things happening there, and there is everything related to blockchain is similar type of discussions enabling these kind of things. There are, I can give you some pointers to in the emails afterwards to some of these industry reports where you see a lot of these kind of companies listed. But every 2 months there are more companies, and some companies they are disappearing. So it's a very lively market.
Okay, thank you very much, Tom. We have another question from Philippe Dujardin. He is wondering, would it also be able to or possible to apply data analytics in global logistics? And do you have any examples for that?
Yeah, so we have been seeing examples into, let's say, long haul transportation type of things in terms of managing container flows and managing empty containers and somehow predicting empty containers and where they are at one moment in time and getting around to that. Of course, in port logistics, you also see many of these kind of elements also in air, making use of more advanced data analytics and somehow forecasting better or more in-depth, detailed prediction type of models are being, you see them more and more happening. And of course, anywhere where you use a sort of how can I say anywhere where you use a sort of a simulation type of exercise, which we now would call digital twin, you would of course get that into a much richer type of setting than what it is now, and with advanced data, more data. So my idea would be that anywhere where you have a huge amount of data available, you would actually be able to learn from that data and improve upon that data somehow and improve upon the processes based on that data. And global logistics is one area where there is an abundant amount of data. Maybe not integrated, but that's another discussion from the data ambition matrix.
Something for a different webinar, maybe.
Yes.
Another question that we have received is actually considering the supply chain of lithium-ion batteries for electric vehicles. So that's the context. And then, Tom, in your opinion, what would be the best supporting technologies for its digital transformation? Also a very specific one.
That's I have no idea. That's I think it's also good to say sometimes that it is a very
honest question.
It is a very specific question, and I would probably need a little bit more context and domain knowledge about how this specific supply chain is operating and also what would you need, because again, digital transformation is a very broad type of concept. So I would say, you will get 2 or 3 students. We will try to understand your domain better. We will try to understand your problem better. And if we understand your problem, we can also give you a much better answer to these kind of things than what it is now based on these kind of very high level questions.
I think you are now referring to, Tom, the master consultancy projects. So we have our full-time master students within the supply chain master. They work on a consultancy project within a company. So if you have a topic or a complex problem that you want those students to investigate from our supply chain masters, that would be an option. So do reach out to us, maybe in the follow-up email, if you would like to explore that opportunity.
Yes.
Also checking the time, it's 15 past. We have a question from Khalid. Where does a manufacturing company start if it wants to embark on a digital transformation journey for their supply chain? So where do they start?
Good question. I think, yeah, going back to the presentation, I think if you look at this monitoring, control, optimization, autonomy type of kind of flow chart, it starts with monitoring. So if you do not understand what you do in terms of monitoring, track and trace, so the first step would be to make sure that you have the process of collecting the relevant data and having the data available. That is the first step. And then if you go into this circle of this kind of iterative circle, then it means that if you have the data, then you have your analytics, right? So you need to have the knowledge. You need to go up into knowledge also to improve upon, to have the right people that are able to work with this more data rich type of context. So I think it just depends as a company, as a manufacturing company, where in the matrix are you, in the data ambition matrix are you, and where do you want to go to? And again, everything really starts with getting your data right. Without that, yeah, then it always stays a bit like an ad hoc, a very people-based type of journey, which you might not want to do. Or some sectors might want to do that, I don't know. But that's, so I would say data, start with monitoring data.
Okay, thank you so much, Tom. That's it actually for the questions so far. Is there anything from your side, Tom, that you would like to share in general as a concluding thought? Or
so I think the last I think it's really a journey, and that's the digital transformation is not something with an end point, but it is something that keeps on going for forever probably. But the important part is that it is actually stepping up on these levels each time. So if you do not do step one, if you think you can do, let's say, planning and optimization without monitoring something, yeah, then it will never be making sense. So it's really a journey into improving yourself. And it's really, first you need to crawl, monitor, then you can walk, control, and then you can go to the next step. So if you don't do that, then so it is nonsense to think you can do AI if you want without all the other steps. That's my opinion, and that's maybe also a good concluding remark.
I think that's a very nice closing thought. So thank you so much, Tom, for all the valuable insights. We're receiving a lot of positive feedback in the chat as well. So what was shared today is actually just the tip of the iceberg. It's just a warmer up. So there is much more to share on how you can further improve your supply chain in general. So should you want to dive deeper into that and get the full overview, Tom has not mentioned it yet, or yes, he has mentioned it briefly at the beginning. We have a masterclass that is organized twice a year. Once we organize it online, starting in fall, that will be in December 2022, and then once we will organize it on campus in springtime, so that's March, April. So if that triggers you to find out more, to dive deeper, and you want some further information on that masterclass, you will receive info in the follow-up email already, together with the presentation, the white paper, and also the recording. But if you're triggered to find out more about the masterclass, do reach out, and then we can have a look at it together if it could be something for you personally or for your organization. So that's it, actually, basically. Thank you, Tom. Thank you, everyone, for joining from home or from work, and wishing you a wonderful rest of the day.
Thank you very much. Bye-bye.
Thank you. Bye-bye.